that we are predicting is for y equals to 1. Fine. So let's say your classification result say 0.3. The answer of the classification is 0.3. So the meaning of this particular 0.3 is, given all the features, probability that the y value, or you can say the label, is 1, and that probability value is 0.3. Are we clear? We'll just have one output, that is one value between 0 to 1. Right? But you must know what is the meaning of that particular value. Right? So let's say whenever you are predicting some answer given some x values, your answer might be some value which is between 0 to 1. So let's say that value is 0.3. So the meaning of this 0.3 is the class label is y, which is equals to 1. You can say the class label is 1 with 0.3 probability. Fine. And we know that it's just in probability. So the summation of this p event and p of not event would be 1. So in our case, probability of y is equals to 1 plus probability of y is equals to 0 will be 1. Fine. So what will be the probability of y is equals to 0 in this example, in this particular discussion? Probability of, so that is the class value 0. Devang, 0 is the prediction, you can say the class value, or you can say the answer, right? But the probability value that we are considering is 0.7 for y is equals to 0. Fine. Okay. So once again, keep it in your mind. We'll just get one single value, and that single value is the probability of y is equals to 1. Fine. And accordingly, we'll have the probability of y is equals to 0, and whichever is the highest, we can consider that as an class label. Fine. And the next point is, why should we, why should there is, why there is a need to introduce this probability based model, probability based classification model. So reason for that is, if we use the linear regression over here, is we'll have a very hard boundary. That means we have some threshold, and if the value is greater than threshold, we'll say the class is 1, otherwise we'll say the class is 0, right? But now in this scenario, what you will get, you will get some probability value. Fine. So you can say that the particular features belongs to the class 1 with some probability p1, and similarly it belongs to the class 2 with some probability 1 minus p1, or you can say with p2. Fine. So the advantage is, we have seen two scenario in the last discussion. The one is the probability value is 0.49. Another scenario is probability value 0.51. Fine. So for both the scenario, if you classify your data to one single class, it might be an incorrect thing, or you can say it might be a injustice prediction for the other class. So that's why instead of giving that hard result, this classification algorithm will just give you the probability. So now if you want the hard result, you can just apply your threshold, and you may have one single class value. Otherwise, you can have uh, uh, label, you can label that particular classification with two values, right? Or you can say with both class, and along with both class, you can specify the probability values. Fine. And the perceptron learning, which is, you can say, the initial phase of learning of this particular logistic regression, where we'll just have the hard boundary similar to the previous algorithm. Fine. So this logistic algorithm, or you can say logistic regression algorithm, will use the concept of this algorithm in the neural network also whenever you deal with the activation. And over there, you may heard, or you may have already, you may already know the term sigmoid activation, right? Where the basic idea or intuition behind that sigmoid activation is nothing but this logistic regression, right? So from that perspective also, this algorithm is bit interesting or bit important. Fine. So with this discussion, if we just begin the algorithm, so our h theta value is this g of theta transpose x, right? Where the g value is actually the sigmoid function, right? And in general, you can consider it as an any logistic function. Let's say if you consider the 10 function, right? So once again, you can have, and similar to that, any other function, right? So we'll, in general, we'll refer this logistic term or logistic term with the sigmoid, but that is not the hard boundary, right? You can consider any of that, any of the sigmoid function. So now the sigmoid function, we all know that the sigmoid function is 1 upon 1 plus e raised to minus z, right? For a given value of z. Now, as a z, what will supply this theta transpose x? Fine. So, can you recall what was the hypothesis with a linear regression? Hypothesis value. We always need to map these two. Right. So, if we just generalize, we can say it's an theta time x, or to be specific, theta transpose time x, right? So, in on that particular value, we are applying some function g, where g is actually the sigmoid, right? And our new hypothesis is something like this. So what would be the advantage of this? So now, if you observe the graph, previously we'll have this kind of division between two classes, but now the division, or you can say with the introduction of this particular logistic function, the division looks smooth, right? So let's say at point 5, you can have change in the value of this particular gz, or you can say there is a change in the class. Fine. So this is a hypothesis, right? So just remember this particular hypothesis value, right? So this is a hypothesis for the logistic regression. And if we try to understand, or if we try to identify what exactly it means, as we have discussed, we are considering the probability of y is equals to 1 given x as well as your weight, that is theta. Fine. So if we consider this example, that is, let's say, cancer diagnosis system, where we have and just consider one single feature, that is, let's say, the size of the particular tumor. So now the x values are x0 and x1, where x0 is related to the bias, so we'll set it to 1, and x1 is the particular size, right? So you can set the tumor size. And let's say if you apply this hypothesis, and the result or the output of that hypothesis is 0.7. So the meaning is there is a 0.7, you can say 70% chance that the value of y is 1. Or in the sense, you can say there is a 70% chance that the tumor is a malignant tumor, right? So we need to take appropriate action on that particular, in that scenario. Fine. So that is the meaning of our hypothesis. And once again, the probability of y is equals to 0 plus y is equals to 1, the summation of the two probabilities 1. Fine. Or in another sense, you can just move this term to the opposite side of equals to, and the answer would be 1 minus probability of y is equals to 1. So probability of y is equals to 0 will be 1 minus probability of y is equals to 1, and given the observation as well as the weight value, right? So this is the hypothesis. Remember, we have three terms: hypothesis, j value, and the third is the updation, the weight updation. Fine. So for now, okay, before moving forward, what will be the impact of this theta transpose x on the result? So let's say if that value is very large, if you just extend this particular graph any of the at any of the end, so that means the probability value is near to the 1, right? And if it is a very negative, then it is near to the 0. Fine. And as we have discussed, if we consider the threshold as zero point 0.5, what will happen? Based on that value, if let's say it is greater or equals to zero point 0.5, will predict y is equals to 1, otherwise will predict y is equals to 0. Fine. And now, similar to a linear regression, in the logistic regression also, you can combine features to achieve non-linearity, or you can say to change your decision boundary. Fine. We know that in a linear regression also, in the last slide we have discussed this term, right? You can just add some term, let's say the square function, you can add the square root or different combination of different features. Fine. And your function now will that will change to, it may change to the function like this, right? Which might be the appropriate function for this kind of data. Fine. So all the discussion that we have completed in the linear regression, all are applicable to this logistic regression. Only changes in this three term. Right. I am repeatedly saying this so that there will not be any confusion, or you can say you must be clear with both the algorithms, linear as well as logistic. The first difference, hypothesis is changed. The second, J value, or you can say the loss function. And the third change is the change in the gradient, right? But eventually we'll see that the gradient will be same, but yes, these three things we need to observe with this linear as well as logistic regression. Fine. So now let's begin. So we have some data points x1 y1 x2 y2 up to xn yn, where we know that the n means number of samples, or you can say number of training samples that we have, and the x value belongs to the d dimension, where d means number of features and y value is either 0 or 1, right? As we are talking, as we are discussing the binary classification, so y is always either 0 or it might be 1, right? And our model, or you can say our hypothesis, will be g, or you can say some function on theta transpose x, and that some function is nothing but the logistic function, or you can say the sigmoid function, which is 1 upon 1 plus e raised to minus z, or if I just replace this value, that will be 1 upon 1 plus e raised to minus theta transpose x, right? Where the dimension of theta is theta 1 to theta d, and similarly x, individual x, or you can say one single sample, will be of size 1. This additional one is for the bias, and the remaining terms are for d features. So previously, for now, let's discuss this second phase, that is this j theta. So if you recall the previous discussion, where j theta was a square function, right? Or you can say we were focused on the square loss, or you can say square error loss. Now, if we use similar loss function, you can definitely use a similar loss function. See, remember that you can use a square loss function, but the issue is if you use that function, your graph might be like this. And this is a graph of something versus something. What is that something something? Can you just recall from the previous discussion? We have developed this kind of graph with the linear regression for some samples, or you can say for some examples. So can you just tell me what is the representation of this particular graph? That is theta versus So over here we have the theta, and y-axis will have j theta, right? Or you can say the error, parameter versus the error. And we know that with the square error function, linear regression, the graph was the convex graph, which was like this. But now if you try the same loss function, then the graph might not be a convex graph, or you can say that will be a non-convex graph. Fine. You can try some examples, and you can try to plot that examples, and you may get this kind of graph. So the issue with such graph is, what was the issue? We have discussed this kind of graph in the previous linear regression also. So what was the issue with such graph? Exactly. There are many local minima. Fine. If you observe, this is, you can say, one of the local minima. We have the second local minima, the third local minima. This, you can say, the global minima. This is once again one more local minima, one more local minima, and over here might be there is one more local minima, right? So it might possible that whenever you train the algorithm, the loss value, or you can say, you may stuck at this any of this local minima. Fine. And we don't want to do that. We need the error to be minimum. That means we want to reach at this particular global minima. So for that, such non-convex graph may not be helpful for us. Right. So that's why we are not using this square error function. Fine. Otherwise, it's fine. Right? You can use any of the loss function. Right? So we need some other loss function which gives us a convex graph. That means a graph which might looks like this. Right? So now, due to that reason, we need to update that j theta function too. Right? And for that, logarithm will be helpful for us. Why this idea of logarithm comes into some researchers' mind? The reason is just we have used the e, right? So just recall the equation of logistic regression where we have 1 upon 1 plus e raised to theta transpose minus theta transpose x. Right? So now if you observe, and that's why this logarithm function will be helpful in terms of derivation. Right? So now if we just recall the logarithmic function, it looks like this. Fine. And now just pay attention and just observe the j theta function or the cost function or the loss function, right? These three terms are frequently used. So many times whenever you refer some material or the literature, remember that either they refer the loss by a cost function, or you can say a loss function. Right? So now just observe this loss function, or you can say the cost function, where we have two different loss value for different value of y. That is, if y is equals to 1, the loss value is minus log of our hypothesis. And if it is 0, the loss value is minus log of 1 minus the hypothesis. Right? Why there is a need to take this two different values for different values of y, that will be clear in the next slide. But right now just observe this thing. Right? Previously, if you consider the square error loss with the linear regression, where we just need to, no matter whatever is the y, we need to do hypothesis minus y and the square of that. Right? But now what we are doing, instead of that, we'll also observe the y. If y is equals to 1, we'll have minus log of hypothesis. And if it is 0, then we'll have minus log of 1 minus hypothesis. And we know that in a binary classification, we just have two values of y, either 1 or 0. And we are right now discussing the binary classification only. Lateral, in the same lecture, we'll see what happen whenever we have the multi-class classification, right? But that will be bit lateral. Fine. Any doubt up to this point? Hypothesis or this loss function or the cost function? Why these two values, that we'll see in the next slide. But any other doubts? Okay. So now, to understand why we have these two separate value, just focus that what will be the graph of this minus log of hypothesis. That means what will be the graph whenever the y is equals to 1. So previous slide indicates the graph of a log z, right? So now if I take the graph of minus log z, it will be the reverse of this. Fine. And we know that we are restricting it, or you can say we are restricting that value between 0 to 1. Fine. So now if you take the reverse as well as if you restrict it between 0 to 1, we'll have this graph, right? Now let's just try to understand what is the meaning of this particular graph representation before moving towards the second part. That is what will happen whenever y is equals to 0, right? So we'll discuss that part also. But before that, let's just try to understand. So this x-axis indicates your hypothesis, right? And hypothesis equation, can you just recall hypothesis equation? Which function we have used? Sigmoid function, right? So this our sigmoid function, right? And the hypothesis value between that is a probability value which will be between 0 to 1. Fine. And at y-axis we are representing the cost. Fine. So now if you observe, whenever cost is less, or you can say whenever the hypothesis value is 1, the cost is almost 0. And whenever hypothesis value is 0, the cost is almost, you can say, infinity. Once again, whenever hypothesis, or you can say your prediction is 1, the cost value is 0. And whenever prediction is 0, the cost value is infinity. Remember that this discussion is, you can say, the cost for y is equals to 1, or you can say the true class is 1. So the meaning of this point is true class. That means y is equals to 1, as well as your prediction hypothesis result is also 1. So prediction equals to the true value. And that's why we have a minimum cost, or you can say that's why we have the zero cost. Right? And now consider this part where the hypothesis prediction is 0, the correct class is 1. So you can say totally opposite prediction, right? So we need to penalize this particular cost function, or you can say this particular learning, or you can say we need to penalize by keeping this theta value very large. So for that, the cost value should be very large. And that's actually the result over here, right? So cost moves towards the infinity. Right? If you just put that value into this log function. Right? So if I just put that 0 over here. Make sense? So that's the correct indication for y is equals to 1. Fine. Now if we focus on a second part, that is what will be the cost function whenever y is equals to 0, then the cost will be like this. And you can just plot the value, different values of this hypothesis over here. You can just put the values of hypothesis between 0 to 1, different values, and you will get this kind of graph. So for example, let's say whenever the hypothesis result is 0, or you can say your prediction is 0, so the costing will be minus log of 1 minus 0, or you can say minus log of 1. So in that case, what will be the cost value? What will be the answer to this? Right. So in this case, the answer is 0. Right. But let's try to understand what is the meaning. The hypothesis value is 0, right? And in that case, our cost value is also 0. Right? If we just plot that value into this particular function, 1 minus 0, so minus log of 1 minus 0, that will be 0. Fine. So that means we are not penalizing anything, or you can say we are not updating any parameter, or you can say our loss is 0 or the cost is 0 if hypothesis prediction is 0. Why? Because this is the equation of y is equals to 0. That means your correct class is also 0. So correct value is 0, your prediction is 0. So in that case, cost should be 0. Right? So that is actually the indication, you can say there is a meaning of this point. Fine. And another scenario, whenever your prediction is, let's say, 1, hypothesis prediction is 1. So that means we need the cost value to be maximum. Theoretically, it should be infinite. Fine. So now if I put 1 over here, instead of hypothesis, if I just put 1, so minus log of 1 minus 1, so that is 0. So minus log of 0, right? And your result is, you can say, very high cost value. And remember that practically, whenever you implement this algorithm, just remember, or you can say, just try to handle this infinite value. So if your prediction is totally wrong, then you have to handle that value, right? Otherwise, what happens? The Python will generate not a number. Fine. So in this week's practical, we will discuss this logistic regression itself. So at that time, make sure that whenever it move towards infinity, you can consider some higher value, right, or some appropriate values, rather than just putting whatever is the result of this prediction. Fine. And now if you observe the graph, or if you observe the curve, there are no other local minima. There is only one, you can say, correct value, or the one perfect answer, which indicates the cost value, or you can say the j theta value. Fine. So this is the cost value, or you can say j theta value. So you might wonder that in a previous slide we were discussing this as an cost value, but now in this slide we have updated it to this j theta, or you can say this new equation, a very large equation, right? So just spend a moment and just try to understand what exactly we have done in this equation. We have combined these two values, and we have tried to generate one single equation over here. How? Let's see. First of all, this minus sign. So we have that minus common over here. And now inside the equation, we'll just have the summation. Fine. So this, you can say, the first term, log h of x, that is your first term, and log h of 1 minus x is your second term. Right? Whenever, so let me just write the number 1 and 2. Right? So whenever y is equals to 1, which function we want to enable? 1 or 2? 1, right? So if you observed, the result of this 1 is multiplied with y, and so if it is 1, this is true, right? Now let's observe the second half, that is 1 minus y, but what is y right now? That is 1, so 1 minus 1 0, so this second term will get cancelled out. Fine, so once again we'll have the same equation for y is equals to 1. You can say the first half, right? Now similarly observe what will happen for the second half, that is what will happen whenever y is equals to 0. So if y is equals to 0, the first half will get cancelled out because 0 multiplied by something, it will be 0. Second half 1 minus y value, but y is right now 0, so 1 minus 0, so it will be 1, so this will be enabled. Right? So this is, you can say, the representation, the same representation, but now instead of writing the two separate value whenever y is equals to 1 this equation, y is equals to 0 this equation, instead of writing it like that, we have combined it into the single equation with the help of this y and 1 minus y. Fine? And if we just write it like this, cost of h comma y, where this cost value, that is actually this minus and the full term. And so this is the cost function of your logistic regression, right? And just try to compare this cost function with a linear regression cost function, right? Where we have squared error function. Right? And you must clear that why we haven't used the square error, right? So it might possible that somebody may ask you that, can I use the square error? So your straightforward answer is yes, we can, but it may lead to the local minima. So that's why we are not using that squared error function, right? Otherwise, if you just say that no, for the logistic regression there is a function, and for the linear regression this function, so you must know why the difference is there and why we are not using that square error loss over here, right? And in your free time, just try to plot this squared function with this hypothesis of logistic regression, right? And you may observe many local minima, right? You may develop some Python code with different values of x and y. You may plot the graph and you may observe the local minimas, right? Next, in the discussion of linear regression, we have discussed this regularization. What was the role of regularization at that time? Right, so to avoid the overfitting, the regulation was used to avoid the overfitting. And if you recall the equation, the regulation equation is similar to this particular value. So that is whatever is your error function, or you can say whatever is the loss value, plus 1/2 for all the theta values, the square of the theta. Right, so this we have seen in the linear regression also. So the same regulation you can use over here. But now the change is this j theta is now changed to this equation compared to the previous loss function. Now the loss function is changed. Otherwise, there is no change in regularization, right? Or in another term, if you want to write, you can also write it as a second norm of your result. Right. So story up to this point is our hypothesis is now changed. Previously, it was just theta transpose x, but now the hypothesis value is 1 upon 1 plus e raised to minus theta transpose x. Or you can say in a term, the hypothesis is now the sigmoid function, or you can say the logistic function, and that's why the name is logistic regression. So That is the first change. The second change is we have changed the loss function. Previously we were using the square error loss, but now we have changed it to this particular value, y into log of h of x plus 1 minus y into log of 1 minus h of x, right? And the reason for this is to avoid the local minimas, right? Can anyone recall what is cross entropy, or what is cross entropy loss? Before going towards the third part, that is the gradient descent, can you recall what is cross entropy or cross entropy loss? Or in another sense, let's make it simple. What is the entropy? Other than cross entropy, what would be the entropy equation? P log P, right? And what about the cross entropy? Okay, I guess we haven't discussed that, right? Okay, so maybe in the next lecture I will prepare one or two slide for that cross entropy also. So at that time it might be more clear, and I will add that slide in this discussion also. So my mistake. I am supposed to print. I am supposed to add that slide. But fine. So there is one term cross entropy. So we'll introduce maybe in the next lecture that term. So now if we continue with the other discussion, so just read or just pay attention towards the first line, that is the loss function, right? And don't get lost over there. So at initial level it might look difficult, but simply if you divide this equation into three parts, where the last part is your regularization, this part is for y is equals to 0, and this part is for y is equals to 1, right? Then I guess the understanding of this particular equation will be a bit easy. Next, for the gradient descent, we know that the parameter updation we were writing this equation, theta j is equals to whatever is the previous value, that is the old value, minus alpha time partial derivation of your j theta. Fine. And now if you try the partial derivation on this value, or you can say on this j theta value, by putting the hypothesis as well as by considering the log, eventually if you reduce the equation, you may get this result, which is actually the same function, we can say same gradient descent as a linear regression, where for the theta 0 we do not have the regularization part, as well as we do not have the x0, or you can say the x0 value is 1, while for the other j, that is for other theta values, what is the range of j? In this case, what is the range of j? That is 1 to d, right? So don't confuse that. Over here it is written j is 0 to d, but this 0, for this 0 we have separate equation, right? This just means that we need to update all the theta together, right? Otherwise the j range over here is 1 to d, and for j is equals to 0 we have the separate equation, right? So it is almost similar to this linear regression, except this 1 upon n, but this is in this hypothesis, right? The previously hypothesis equation was changed, but right now this hypothesis equation is different. Fine. So practically if you try to implement this gradient descent, the calculation will be same, but the input that will supply, that will be different, right? The hypothesis is different, where we have the sigmoid function, right? So we have discussed three part. hypothesis, which is different, then the loss function, once again different loss function, and the gradient descent, which is almost similar to the linear regression. So this discussion was for a single class classification. Right. Now, for the multi-class classification, we can use a strategy that we have defined in a very initial lectures, where one versus all strategy you can use. And what do you mean by one versus all? The meaning is, let's say, let's just consider the right-hand side diagram, and we are finding the logistic regression with respect to this diagram. So let's say first we'll try for the circles. So this is, you can say, your class, and for that whatever are the observations. So for this 1, 2, 3, 4 observation, we'll set y value to 1. Fine. So total 4 plus 5, 8. Total 12 examples we have, and out of these 12 examples, for this 4 example, we'll set y is equals to 1, right? And for all remaining examples, that is for this triangle as well as for this square, we'll set y is equals to 0. Fine. So now it's binary classification. You can perform the binary classification and you can predict the result. Fine. And you will get some probability value. Right? Hypothesis result, whatever is hypothesis result, let's say you are getting hypothesis result as 0.4. Right. So this is for this circle. Right. Next, what? We'll repeat the same practice for a square. Next, we'll repeat the same practice for a square. So now this 3 will be labeled as 1, and the remaining examples are labeled as 0. Right? And assume that whenever you try to fit the hypothesis, the answer for this square is, let's say, 0.7. Sorry for this writing. So answer is 0.7. Right? And same practice will repeat for the triangle too. Right? And let's assume that for the triangle, your answer is, let's say, 0.5. Fine. So now what we'll do, we'll convert this multi-class classification into 3 separate binary classification, and we'll proceed exactly the same way that we have discussed in the previous slides. Fine. And for all 3 classes, we'll try to predict the probability of that particular class. Fine. And we'll choose a one which having the highest probability. So now, if you carefully observe, first of all, if you just observe this equation, the first equation for the 2 class, or you can say for the binary class, this one, you can say there is a weight which is assigned to y is equals to 0, right? And this is the weight which is assigned to y is equals to 1. And how we have retrieved this equation? Just simplified this particular equation, where e raised to minus x, you can represent it as a 1 upon e raised to x. And then the simplification of that would be e raised to x by 1 plus e raised to x. Fine. And now for, if you have C classes, so to predict y is equals to some class C, which where this small c belongs to the capital C, given x and all theta values, will have this equation. You can say exponential, and will have the summation of all the exponential, or you can say all the class values. This is a very important function referred as the softmax function, which is most frequently used in any of the classification algorithm as a last activation layer, or you can say the last layer, where we are predicting the class probability. So we'll have a different result, or you can say different probability values. So you assume that if we have 100 class, so for all 100 class, we'll have a different probability value, such that sum of all that probability, or you can say sum of all that 100 probability, will become 1, right? And that will be ensured by this denominator. Fine. So in that scenario, this function will refer as a softmax function, or you can say the multi-class logistic regression. But most probably in many of this literature, you may find it as a softmax function. Right? So that softmax is nothing but your logistic regression itself, but we are using that logistic regression with multiple classes. And we'll assure that for all the classes, the final probability, the summation of final probability will be 1. Right? And as we have discussed, you can divide your data into 1 versus all. And accordingly, you can calculate the probability values. Right? And other all the computation, or other all the equation remains same. Only the change is from all that final result, or you can say from all the probability value, will select the one with maximum probability as in final answer, or you can say as in final prediction, or you can say as in final class. Right? And once again, recall that for all C values, the summation is 1. Right? Next, let's just focus on this particular slide. Let's say we want to calculate the gradient of this square function. Assume that we have used the square error function, square error loss, and now we want to compute the gradient. And remember that this function is our sigmoid function. Right? So if we just proceed step by step. So first is using a chain rule. You can consider this as an, let's say this is the x square. Right? So we know that for the x square, the partial derivation is 2x. So that is 2x. And by applying a chain rule, we are moving, we are keeping this partial derivation, because this function is a dependent variable, right? So we cannot just consider it as a constant. For the y, as it is a true y, that we will predict, we will consider as a constant, but not for this function, or you can say not for your hypothesis. W means with respect to theta, right? Remember that we have identified that in literature, frequently we replace W with theta and theta with W. Right? So now if we just simplify this term, this 2 and 2 will get cancelled out. We'll have f of x minus y multiplied by the gradient of f of x, where this will assume it as a constant. So the constant's partial derivation is 0. Fine. What next? Let's just feed the value of this f of x in the equation. And so the f of x is our hypothesis, that is the sigmoid function. So that is 1 minus 1 plus e raised to minus wx, right? And plus bias. Always the bias term is there. So once again, don't get confused. This w is nothing but the theta value, right? And I'm using this both notation so that whenever you refer some other literature, you may always able to map that this W as well as theta both are the same thing, right? And instead of writing this Wx plus B, I can also write it at Wx. So in that term, my x value starts from 0, right? And we are considering all the features. But if you write plus B, that means that value starts from 1. Similarly, W starts from 1 up to D. Once again, if you use this notation, meaning is W, the range of W is 1 up to D, right? And if you use the other notation, where if you just write e raised to minus Wx, if you don't write this plus B, if you don't write the plus bias, so the meaning is now the W belongs to, or you can say the range of W is 0 to D. Instead of 1 to D, it is now 0 to D, where W0 is related to the bias term, right? Or fine. So these are once again two separate notation that you can use alternatively. So now let's try to see what will be the partial derivation of this. So we'll consider this as an 1 upon x. So what is the derivation of 1 upon x? So that is minus 1 upon x square. Fine. So this we are replacing it with the minus 1 upon x square, and once again we'll moving this particular partial derivation inside by using a chain rule. Fine. And now for this partial derivation, e raised to minus x. So partial derivation of e raised to minus x is e raised to minus x as it is. And once again using chain rule, we are moving this term inside. So now I guess it is easy for you to predict which will be the next term. Over here we'll have a wx. So partial derivation with respect to w, and this b bias, that is the constant. Right? So the next term will be minus x. Derivation, partial derivation of w with respect to w, that is 1. So this result is minus x. And this minus minus get plused. This will be your next term, right? So if you observe, this is nothing but your f of x, or you can say your hypothesis, right? And this term is 1 minus hypothesis x as it is. Fine. So we can just feed this term over here. Right? And we'll have this as a final result. Fine. Similarly, with the log based loss function, for that particular function, try to find what will be the result of this gradient. Right? So with this, we are concluding logistic regression function, and in the next lecture, we'll start the next algorithm.
Is it audible now? Okay, so we are continuing this. Let me try one more setup. Let me know if I am audible to you in that setup. Am I audible now? Okay, so let us keep with this. Let us continue with this. Okay, so let us continue with this. In case of any trouble, let me know. We can have another setup as well. Okay. Fine. So, what is the point? Like today, in short, we are going to try with different noises, and then we will try to remove those noises. So, first, the first noise that we will take is Gaussian noise. Okay. Then we will go for salt and pepper noise, gamma noise, relay noise, etc. Noise we are going to learn. So, uniform noise. Okay. What I know is that if my image is having three different intensities, whatever shape of my noise is, that noise is available. The noise shape is a PDF shape is available at the location where the my intensity exists. Suppose my intensity existed here, so I will have the shape of the Gaussian PDF shape here. Relay shape you can see. So wherever the intensity were existing, there my shape of the noise get copied, right? They were, because my intensities were separate enough, they were far enough, that's why it was possible to have three different curves. The intensities are nearby. If intensities are nearby, then what will happen? One shape will come here, like if intensities are nearby. Is looking like, suppose my intensities are looking like this. These are the intensities present. So what will happen? The Gaussian curve for this will be like this. Gaussian curve of this will be like this. Gaussian curve of this will be like this. Same way. So what will happen? The, the, the combination of this curve will have different shape. That is a separate problem. Here, why the shape was clearly visible? Because my three intensities were separate enough so that I can see the three different shapes. Okay, here same thing is for all. Same we have seen with the example also, that if this is the shape of my noise and if this is the PDF, then the noise will get shifted at the location or nearby location of my intensity. The shape is shifted at the location of my intensity, because what we have considered, a noise is additive. It is getting added in my original intensity. That is what we have assumed. Okay, so this is what we are going to learn first. Okay, this is what we are going to learn first. So now, first of all, I will make this type of image, which is already available in chapter 5 images, but we don't want to try with this. Let us have our own image. Let us learn first image synthesis. So first goal is our image synthesis. Today we learn to synthesize the image first. Then we will add the intentionally we will add the noise. Then we will see the histogram of it, and then we will proceed with that. Okay, let us start one by one. So this is what the concept that I wanted to remind you. You should recall this concept. Okay. Now we are starting with the image synthesis. Here, I want to synthesize one image. This area is dark gray, this area is white, and this area is black. Assume the intensity of this is, say, 128. Assume intensity of this is what we can say is, let us have 200. Let us have this intensity as 200. Okay, and one intensity is, let us take this intensity as, say, 50. Let us take this intensity, because it is black, so it will be near to 0. This is white, so it will be near to 200, 255. You can take this as 230 as well. Let's take this 230. And let's take this as 128. Consider this as what we can say, 600 plus 600 image. Consider it as 600 cross 600 image. Okay. I want to synthesize this. That means this is 200 and this is 400. Okay. So now tell me how to synthesize this image in Octave. Give me the code to synthesize this image. What I want one matrix of 600 cross 600 in which first 200 columns should be gray, next 400 columns should be white, and next 200 columns should be white, and next 200 columns should be black. How to synthesize this image? Give me the code for the same. Are you getting my question? Are you clear with my question? What is my question? Suppose, okay, so how to start? I want to synthesize this image. I want to create this image. I want to generate this image. What I want, you can see this as matrix of 600 cross 600. Yes, you can start with yes, you can start with zeros of 600 to 600. So all zeros are created. Let us together. Let us copy that the same code we can copy as our regular practice. So okay, so I'm copying this code. I feel that it is true. It is, but it is not sufficient. No? It is just zeros are created. What next? After that, what should be my next step? Yes, for loop is not required. Of course, you can go through for loop, Jaimin, but Gata's idea seems better. It is simpler and faster in execution. So we will go with Gata's idea. What she says that take all the rows and take first 200 columns and make it 128. True. Take all the rows. That is all. The column is for all the rows, and first 200 columns make them 128. True. That is true. So first gray shade is created. What is expected next? Still something is remaining, right? What it is? Yes, it is 201 to 400. Make it 200. I am assuming not 255, but I am assuming my intensity is 230. Fine. Whatever your intensity is, keep that intensity here. Right? And what I want is my black should not be zeros. It should be my what we can say. It should be 10 value or 15 value. I don't want the extremes here because I want to see whether the entire shape is copied or not. Because I know ultimately I want to see whether Gaussian is copied there or not, or what we can say, or so uniform noise is there or not. So if it is extreme, I'm not going to get that values as I want. So don't have extreme values there. Don't have 255. Don't have zero values. Just have like 50, 10, or you can have like 230, 240 like values, right? So that we can get. So some scope will be there. Otherwise, any value beyond 255 will be 255. So we will not get the shape proper. So better you take intermediate values for understanding purpose. So now one more thing is required. I will change it to 4012 600. 4012 600 should be not 0, but it should be 50. Okay, so now three values are defined. Okay, and if I will write like I am show, I'm going to get desired image. Let us see. This is also fine if you are taking, but you should use ones instead of zeros, man. Zero will get multiplied with 128 will be zero only. Na? You can write with ones, it will work, I guess. Right? You should go with the ones instead of zeros, otherwise it will work. Yes, this function is also going to work. True, it will work. So whatever you use, whether you, so man's idea is also fine. But what he has done, he has taken first 200 columns with zeros, and then 128 is multiplied with ones. Assume that there is a ones here. So with next 200 columns and 600 rows are multiplied, and they should be kept in the in the row element. So I think it should work. It will work. But just the point is, it should be here once. You can try. Fine. So as expected, the image is created. Any shape you can have. This is how image synthesis is possible. You can create your own image, right? Your own expectation. You can have your own image. So my image is created here. Now, what is my expected histogram here? What will be my histogram? If it is not a noisy image, it is regular image. What is my expected histogram? What is expected histogram here? Spikes at which intensities? I will get spikes is 3 bars and location of the bar is of the x location of the bars are, yes, it will be 128, 230 and 15. True. True, yeah. Yes, Vivek. It is 128, 230 and 15. True. Fine. So that is what is expected. So let us see. You can use your own histogram function as well. But right now I don't have mine, so I am using the inbuilt one. But it is expected that you will use your own created histogram function. But anyway, I'm using this. I'm using stem. I know my intensities are from 0 to 255, and y-axis should be y. So this is how it is going to work. As expected, we are getting on that we need to check. Is it giving us some error? Okay, IM list is not defined here, so we need to load the package. Okay, this package load package image or image. What you should do? Okay, package load image. I should load the image package. Okay, as expected, the intensity values, if you can see, this is 15, this is 128, and this is 230. As expected, 3 bars at the location. Okay, and these are the counts of the number of pixels. That is 200 cross 600. Right? As expected, 3 are equal. So we expected this histogram and we obtained. Okay. So here I think I should use figure for the stem. Okay, fine. So I have the histogram image synthesis is over here. Now what I want to generate the noise. So I have some functions. One function is random. Okay, I want to generate the noise, right? What I want is my noise is additive. Okay, so I want that certain intensity should get added to my current intensity. My noise is additive. What is the meaning of that? Extra signal, extra image with different intensity is going to get added to my image. That is what my expectation is, because my noise is additive. Okay, so I am going to add certain number in my image, in my intensity. Okay, and what is the probability of occurrence of my those numbers? So I am going to add some random number here, right? I am going to add some random number because noise is random, right? So I'm going to add some random number to my current intensity, current image, so that the image intensity is going to vary, and hence I'm going to get the noisy image because it is not my actual image, right? So I want to generate a random number. That is what my requirement is. Now, random number can take any value, but certain things we know about that random number. What it is that we can see here is if my random number uh, follows this type of PDF. If my random number follows this type of PDF, that means probability of occurrence of this value is maximum. Probability of occurrence of this value is given by this equation. Any value it can take any value. But the probability of occurrence of this values varies with respect to this curve, then that noise is known as Gaussian. If it varies with respect to this type of curve, then it is known as relay noise. Understood. So what I want to do is I want to generate random number which I am going to add to my image, and that random number while generating should follow this probability curve. That means it can take any value, but probability of taking those value will follow this curvature. Same way, if it is following this curvature, I will say it is relay noise. If it is following this curvature, I will say it is Erlang noise. Okay. So now for that I have several functions. I have to generate anyway random numbers. So I have random function. I have random n function. I have uh, random g function, random e function. So what is your job? Your job is to read about it and tell me which function should I use to generate which kind of noise. That means random function if I am using, which kind of noise it will generate. That means generated random numbers are following which kind of curve here. Okay, so that is what your job is. So first of all, get to this. Either you can use your internet or you can use the Octave help. No issues. You can use anything. And just give me the idea that if I'm using random number, then generated random number will follow which probability curve. So which noise actually I have generated. Okay, so tell me for all four. I'm waiting for your answer. Are you clear with the question, na? All of you? Are you clear with the question? Should I repeat the question? So, Chintal, should I repeat or are you clear with the question? Okay. Are you first let me know, are you clear with random number is going to generate a noise? Okay, fine. So what will happen? Suppose in my image there are some intensities in my existing image. If in my existing image, what will happen? I will have some intensity, right? Okay, some random number is generated, and if added here with this whatever the intensity I had earlier, then I will add some other value to that. So definitely intensity value is going to change now. So now whatever new image will be created with the added values, it will be my what we can say, it will be my noisy image. So now my random, so here it is possible that I have generated random number say 3. Random number I can generate any number. I am generating random number say 5 here. I am generating random number say 7 here. Again I am generating random number say 3 here. Again I am generating random number say 3 here. So I can have a histogram or I can have its PDF as well. What is PDF? It is normalized occurrence. So I will say okay, out of, so I can find out how many times 3 occurs. Then divide by total number of generated numbers. Okay, so whatever the value comes, I am going to draw it here. Then I am going to find out for the 5. Suppose it is this. It is this value. For 5, the normalized occurrence, so normalized PDF is this. That is the total number of occurrence divided by total number of generated numbers. So in short, what I did, I added random numbers to all the intensities here, and I found its histogram. I calculated the histogram of the generated random numbers only, not the modified intensities. What I am calling about is I just plotted histogram of the generated random number. That means actually I plotted the histogram of the noise. Noise is what? This extra numbers, this extra signal is noise, na? These actual intensities are my signal. These extra numbers are my noise. So what I did actually, I plotted histogram of my noise, normalized histogram of my noise, and if I found that that number that the generated numbers are following this type of curve in the PDF, that means the histogram is having this type of shape. That means the generated numbers are following Gaussian distribution. That means the noise is of a Gaussian type. Suppose I am drawing this PDF, and if it is taking this type of shape, if it is following this type of shape, then I will understand, okay, because it is generated numbers are following exponential distribution, and hence my noise is of exponential type. I hope it is clear now. So now my question is what? That so anyway I am going to generate a random number. To generate random number, I have four options: random, random n, random g, random e. These are four different functions available in Octet. My question is, if I am using random, then random numbers will generate it. Random n will also generate random number. Random g will also generate random number, but they will use different histograms. They will use different distributions. And my question is that which distribution is going to which distribution should generate, I mean, if I want to generate Gaussian, which function I should use? Okay, so I think some answers are there. Yes, yes. So here Nidhi is correct. In random E returns the matrix with exponentially distributed numbers. That means the numbers that are generated will be exponential in nature. Okay, so if I will draw the curve of exponentially generated numbers, it will follow this. That means random E is going to be helpful in exponentially for the exponential noise. Random E, if I am using random E, it will generate the exponential noise. Random G will return the gamma. That is true. It will generate the gamma, this noise. Okay. Beta says random function is for the uniform distribution. True. Random and for the normal distribution. Normal distribution is something but the Gaussian distribution. So that is true. Random and for the normal distribution, and normal distribution is something but the Gaussian distribution. Random E for the exponential distribution, and random G for the gamma distribution. That all are correct data. First it fall. See what random is. What I know the what are the see some parameters are normally higher. We don't know what will be the exact value. We don't know that after 5 3 will be generated. We don't know that after 5 3 will be generated, or 7 will be generated, or 5 will be generated. But total number of occurrence we know. Some statistics about the noise is known to us, and that is what our prior condition, that something about the noise must be known to us, right? And that is what our assumption is, that we should know something regarding to noise. We had that assumption. Random is, it is random in terms of why it is random, because we don't know. uh, yes, so see, yes, so what was your question regarding to randomness? Randomness is what we know the range of outcome, we know the probability of occurrence of outcome. Like see, suppose I am having, I'm tossing a coin, right? And whether it will be head or tail, I know whether the answer can be head or it can be tail. I know the probability of occurrence of both is 0.5 if it is a fair curve, right? So that then also we call it a random number. The same thing is there. Randomness in terms of it is in terms of occurrence, right? So they are random. Janam, I'm coming to your point. Let me check others. Yes, Ruchik, random is available for the Poisson distribution, but as we have not taken, we are not going to, because we have not taken. See, various type of noises are available. Poisson distribution is also there. Many other distributions are there. But as we have not taken that in our theory session, we are not going to take it in the laboratory session as well, but definitely you can try. Um, yes, sir. These functions, Maliha, are created not for the noises, they are for the random number following particular distribution. Those random numbers we are going to use as noise. So these functions are created for generating random numbers of particular distribution, that's it. Now those randomly generated numbers are going to behave as noise for our case. Okay, so that's why it will be, we will use it as noise. Random I is for generating integer numbers. Yes, Akshay, it is there. If needed, we will use it. Otherwise, yes, of course, you can use it if you want to generate random integer numbers. But Akshay, can you check it out that which curve it follows, like which distribution it follows? I could not find. That's why I avoided it to use it. If you can find, that is of more use. Random I follows which curvature? Like it follows Gaussian, gamma. What? I could not find, so I avoided it. It is not given. I could not find it in the document. But of course, you can check and tell me, Akshay. Um, that is fine, but it returns the numbers, but it follows which curve? What is the probability of occurrence of values in the range of 1 to I max? Which curve it follows? Okay, so you can check that in. I could not find. In case you find, you can tell me now, or you can tell me in the next laboratory event. It's all right because it will be highly useful. Right now, I don't have that information, so I'm not going to take any random distribution and can check. Right, so that's why I will avoid random I. But of course, it is useful if you can find out the distribution of it. Relies on random, so it is possible that it will follow, Jamie, it may follow the uniform distribution. If it is the given thing, it relies on random, then uniform distribution, right? Uniform distribution of integers. That's good. So if in case uniform distribution is needed, you can go with the random I. Right? I have not tried, but definitely we can go with the random I. We will try that in this laboratory session itself. We will see whether it actually follows the uniform distribution or not. Jaimin, what was your Jainam? Jainam, what was your earlier question? Okay, so random and random I both are uniform distribution, right? Fine. So we can go with the uniform distribution because it will be of more use. It will be more useful to us. Jainam, can you what was the question? I forgot your context here. Can you repeat your context in question? What is that? That we cannot call it as some specific mathematical equation. I could not understand the context. Please repeat your question with the context. I forgot the context here. Yes, it is. The curve is mathematical. The equation of that curve will be mathematical equation for the probability of occurrence. Right? It will be like what I will not get which next random number will occur, but I will get that what will be the probability of next number. Suppose the current number is 5, and if I am checking for 6, if I am substituting, if I'm suppose currently my generated number is 5, right? I can show you in the curve as well. Okay, so where we were here. Suppose my current value is, suppose I am currently at my current generated value is 5, suppose. And if I want to check 6, so by substituting the value 6 here, by substituting value 6 here, I will get the probability, I will get what I will get by substituting value 6 here, I will get this value. I will get this value. What that value indicates? That value indicates probability of occurrence of 6. It will not tell me what will be my next value. It will give me what is the probability of occurrence of particular. Okay, so whether it will be 6 or not, that I don't know. But if what is the probability that next number will be 6, that I can get. Okay, fine. So now our next task is to generate. Let us generate the random number. Okay, let us generate the random number. Now what I want to do is I want to generate uniform noise. I want to generate first uniform noise. Okay. That means, and I want to generate it in the range of 10 to 20. I want uniform distribution between the range of 10 to 20. First of all, tell me which function I should use. I want this type of distribution, and my value is here 10, and this value is 20. First, tell me what should be my equation. How should I, which function should I use first? So you may say random or random I, right? Whichever function you want to use, you have to give me the equation. So I'm not concerned about whichever equation you feel that we should use, that we can. I'm ready to use. I've not tried random I. I'm sure about random, but of course you can use any function. Just give me the code, whatever you want to do. What I want is from 10 to 20. Uniform distribution between 10 to 20. That is what I want to generate. What is the meaning of that? Suppose I have my image. Suppose I have my image 600 cross 600, right? And I want to generate one more image of 600 cross 600, whose values will vary from 10 to 20. Here, my in this noisy image, value can be 10, it can be 11, it can be 12, it can be anything, right? Value can be from 10 to 20, right? It can be from 10 to 20, and 10, it can be 20. But what is the probability of occurrence of 20? What is the probability of occurrence of 10? What is the probability of occurrence of 11? Whatever the probability of occurrence of 12, all probabilities are equal. So Vivek has given some equation here. What it is? 10 plus 10 into random 600 cross 600. Round function will be needed. Vivek here somewhere. If random is used, then it may generate any number, because it is between 0 to 1. So it is true if I am adding. So this seems correct, right? But this round function is needed. So please add the round function if it is needed, and modify your answer. What will happen here? My values are in the range of 0 to 1, right? So what I want, that 0 to 1 should be, now that range should be into 0 to, if I am adding 10, so it is now 10 to 11 if I'm adding 10 there. But what I want to go for 10 to 20. So what I want, 0 to 1 should be extended to 0 to 10 actually. So this range is actually 0 to 1. Random generates. Fine. You can use round outside, or you can use round with the random function. Fine. I'm copying this code. I feel that it will work. I feel that it will work. Let us see. I'm giving this as some function name or noise n. So this is the noise, and if I draw its histogram, how it should look like? Let us try this much only. The values are not. What is the issue here? Let us try that too. Let me check the values first, and seems fine. It seems fine. Okay, so let us try with. I'm not sure whether unsigned integer is going to help. think it is. Uh, okay, you continue, or you can try your in your you parallelly try as well. So tell me where which food works well. My octave has stopped. Okay, so I will make it small variable n, and we will, and then it says that this will work. Let's see. Let's see. Um, because the IM list also assumes, I guess, is also assuming that the variable should be in the range of 0 to, because IM function comes, otherwise hist function I should use. If I'm using IM hist, it will follow the same case as IM show. Otherwise, you can use your own function instead of going with this any such type of requirements. And those who have completed, and they can go with some generalized one in terms of A and B. Go with A and B, because see here 10 and 10 are for 10, 20 values. Give me the equation in terms of A, B, where A and B I can vary anytime. A is the starting value, B is the ending value. Suppose I say 10, 30, then. Suppose I say 15, 20, then it should work. Right? Let us, I am checking till time. Those who have completed and verified, they can think on the next issue. Okay, so yes, it is working well, right? It is working well. With the uniform noise, see, it is expected that that's good. So you assign it is an 8. Good, Jainik Vivek, that works well, right? Maliha is ready with the answer of A and B. Yes, Chintal and Maliha are both of you are correct. True. So like I'm editing, I'm changing this with your equations, right? I'm changing with your equations. That is true. So this is how my noise is generated. So fine. Now I have to define A and B. A is 10 in my case and B is 20 in my case. Of course, you can vary and check that. And you can see, if you can see, your histogram is almost uniform, but still it is not perfectly uniform. The reason is you are using round function and all those, right? Because it is possible that we generated 10 point something value, but we are rounding out up to 11, right? So that's why it is going to vary. Some little change will be there, but it is not problematic, that much problematic. So no issues there. But anyway, some idea we can get regarding to the distribution. Okay. So now that is all right. So we are ready with our noise. We are ready with our image. Now what is our next step? Let's have noisy image. What should be my equation of noisy image? It is additive in nature. What will happen? Suppose this n is my noise and image is my function image. Then what should be my noisy image? It is additive in nature. So what will be my equation of the noisy image? It is very easy. What it is? Img plus n. And yes, it is img plus n. If I am not using dot chintal here, it will be fine because plus will operate on element wise only. right? So if I'm not using dot, then also it is fine. It will be element wise addition only. But anyway, it's good. It's correct. Fine. So this is my equation. So now it is ready. Noisy image is ready with me. So what I can do, I can use IM show noisy, and here that figure. What I want to check further is its histogram. I want to check its histogram as well. So I will do this as well. Let's save it and let's run it. See, let us compare. Let us just minimize this and let us compare these two first. This is my original image and this is my noisy image. Can you see the difference between two? In your case, if you run that, can you see the difference between two? This is original image and this is noisy image. See, some dots unnecessary. See, this, usually even we will not be able to. Our eyes are having such a great filters. Actually, we can see we can easily identify the information out of it. But if you can see, so many dots are there, so many values are there, and they are going to create. They are going to. They are going to have the impact here, right? They are having impact here. Because it is additive in nature, we are anyway adding some values 10 to 20, 10 value, adding 10 intensity or 20 intensity is not going to have that large impact. But still, some values are inserted, some randomness has occurred here, some values are changed. That is for sure, that we can definitely see from this. Image is comparatively brighter or darker. What you can see, image is brighter or darker. It is brighter, and obviously it is going to be brighter. Why so? Because we are adding intensity 10. So now whatever the intensity was 128, now the intensity from 128 is changed to which range? Now whatever the intensity is 128, the noise value from 10 to 20 is added to that. The noise can be 10, it can be 11, it can be 12 with equal probability. Right? So now my values are changed from 128 to 138 to 148. And what is the probability of occurrence of 128 or 138 is equal to probability of occurrence of 148 is equal to probability of occurrence of 135, whatever you say, right? So sorry, 145, 145. So in short, my 128 range is changed to 138 to 48, right? Same way, 230 changed to what? 230 has changed to 240 to 250. That's why white is white only, right? And what happened here? That 15 changed to, if it was 15, I don't remember whether it was 15 or not, but if it is 15, now it is changed to 25 to 35. What is the probability of occurrence of 25 is equal to probability of occurrence of 26, 27 up to 20, 35. I hope it is making sense to you, and this is what uniform noise is. And that's why this is expected behavior of the noise. Okay. Same way, let us see. This was my original histogram. This was the histogram of my noise, and as expected, this is the histogram of my noisy image. You can see that earlier, whatever the value was at 15, now it is 25 to 35. Earlier it was at 128, now it is from 138 to 148 that you can see, and here up to 250 from we can, what was it, 242, 250. It was expected. Okay. And let us if definitely it will work logically also, it will work, but if you want to make it broad from 20 to say you want to keep it 50, so the histogram copy is going to be broader. It is expected here. Yes, it was expected here. Right? It is more, it is broader here. It is broader here. Right? And so this is expected broad. Now anyone if can I give me the idea regarding to this curve. Can anyone explain me what is happening here in this curve? Can anyone explain me what is happening here? Can anyone justify this curve? What is this? This is histogram of the noisy image. Can anyone justify this value? How this value occurred? Any idea? Okay, what happened? No threshold. How? Which threshold? Yes, threshold. I mean, you are calling about upper limit. You are discussing regarding Maliha. You mean that upper limit? Think regarding to upper limit. What happened to this white value? What was the earlier white value? What was the earlier white value? Yes. What was earlier white value? White value was 230, right? Now 230 is changed to, now what is the new range of 230? Now 230 should be modified to which range? If I am adding the noise from 10 to 50, what should be my new range? This all the pixels having value 230 should get changed to which range? 10 to 50. 10 to 50, Maliha. Yes, ideally it should be 240 to 280, but real is also correct here because all the values beyond 255 is going to get changed to 255. So all the pixels having intensity 255 or 256 or 257, all those values are mapped to what? 255, and hence 255 curve is having highest value there. Because all the white pixels are now converted to 255. No? Understood? That's why this value is so high. That's why these values are looking low here. They are looking very, very less here. Getting the point? Understood the curve? All of you? Okay, fine. So that is all about the curve, and we can see the noisy. When noise is, see here the noise is having more impact. Gray shades are there, dark, bright, all shades you can see. So it is more noisy. It's more noise is added, broader range of noise is added, and you can see the noisy. So this is what uniform noise is. Now I want a function. Whenever I will need uniform noise, I am going to call this function. My own function for the uniform noise. So let us have one more function. I am calling. So I will copy the code from the previous one only. Function output is my noisy image, and input should be uh, my uniform. I am calling it as my uniform. That is my uniform noise. Image is A, and sorry, A should not be my image. My image should be IMG is my image. A is the parameter of starting uniform noise. B is the ending parameter of my noise, and it is having end function. So now which lines I should copy? So this is synthesis of my image, so I should not copy. Okay, I should just take this. And in case, let us have the what we can have here is, then it is my noisy image. then it is my the noise is generated and noisy image is generated. Okay, and this is the histogram of the noisy image. So I don't get this line now. Yes, you can have that in written. You can have histogram in written instead of only noisy image. You can have histogram. We can say Y. That is what I call it. No, Y. I call it Y. I'm calling it Y. What is Y? Y is my histogram. So I will need one package here. So I should copy this. I should. Uh, okay. So what exactly it is written? Y is written. Noisy image is written. Y is histogram. Okay. And what is taken? A and B are taken. So no need to take A and B here. No? A and B will be given. Just to generate the noise, add the noise. And okay, so in case I need, I am going to have this my uniform. Yes, that is true. That is true. Thank you, but I just needed. So I should use capital M N as size of image. And I should use here M. I should use here. And please verify anything else should be edited here or anything else should be changed here. Anything else? Yes, it was needed to change the image size. It was very valuable suggestion. Okay, so I think it is done. Now, so this was my image. I don't need them now. Okay, I can have that, but I understood it. Let us keep it even. What is issue now? Okay, this we can comment. And here I can call as y noisy. Noisy and y. Noisy and y2 as my uniform, and then what you can have is image A and B. I needed A and B. Okay, I needed it. It seems it will work, and the noisy and y2 and it should work. Let us try quickly so that we can use it in future as well. Yes, it is working well. It is working well for this. Yes, I am removing this unnecessary part. And I am having this is for uniform noise. Let's have that uniform noise, right? Okay, but that is sufficient for me. So right now I am not interested in this uniform noise. That is done for me. Now I want to go for Gaussian noise. What will be the change? What should be the change? This is my function. Na? I will have similar kind of function. My Gaussian. Yes, Jamie, it is random and for normalized distribution. Yes, so we should use, yes, well, you should use random n. So, okay, we should use random n. So, so output will be the same, histogram is needed, and histogram of the noisy image can be even calculated outside, but that's all right if I'm getting from here only. Input will be image, but A and B is not required there. So check for the random n. For the Gaussian, what are the parameters? Are they A and B? Check your image. This is for uniform noise. I need two parameters for A and B. For Gaussian, what are the parameters? For Gaussian noise, the parameters are not A and B. They are mu and sigma, mean and variance. I can use random n, that is true, but not directly changing the same thing here. I want my mu and my sigma should be used. Okay. So tell me how exactly, what if I'm not doing anything, random n will give what mean and what sigma? What will be mean and sigma, or variance, mean and variance, not sigma. Standard deviation is all right. I'm discussing about variance. What is mean and variance if I'm using random n? Check your code, check your not help, check your help. Random n gives normalized distribution following what mean and sigma. Yes, mean 0, variance 1. Mean 0, variance 1. Okay. So let us go with this. Okay, suppose I want mean 0 and variance 1 only. Suppose in my noise, then we will see how to modify. That is separate thing. I'm using right now the same mean 0, variance 1 which is provided by random n. Tell me the code line. I just give me the code. I'm going to copy that code. Give me the line of code that I should modify here. Which line I should keep, which line I should remove. Here, first of all, how to generate noisy image. Give me this line. Give me the code for this line. Because random will generate the values between 0 to 1. So what will happen actually? Let me tell you. Suppose I am using, let us see what happens if I am using random n of the same size. So let us see whether this works or not, or why it works, how it works. Let us see. Okay, so I think this is sufficient, but it will not work because this is not going to work. Why? Because values are in the range of 0 to 8, and if I'm using unsigned integer 8, so what I want is, let us, if I'm keeping it like 10 into random n, round off it. Now what will happen? My numbers are generated in the range of 0 to 1. It will get multiplied with 10, so they will be in the range of 0 to 10. Okay. Then they are rounded off and answer into the 8 type. Are you following that point? What I did? I just multiplied with some number 10. For now, I keep it 10. Then I will understand what exactly this 10 means. Okay. Right now I kept 10. I multiplied with 10. I'm saving it and I'm checking it. Now what should I do here? I should just change. I should copy this. Oh, okay. Anyway, I have to continue with my wrong spelling, but I hope you will understand it. So I just want to give, I just want to give this image as input. Okay. And let us see whether it works or not. Bracket issue. Okay, now uh, I think unsigned integer 8 is creating the issue here. We should not use it. No, after addition, we can use unsigned integer 8. Of course, I will tell you what was the issue, or you are going to identify the issue. The issue is with this. Let me check whether it solves. Then we can discuss what was the issue, how it was. Okay, as expected. As expected. Okay. So now, what exactly happened here? Let us. Uh, Here. Okay. What was the case here? See here the values. Okay. What was the range of random? First of all, tell me first what I did here. I took image and I took its size. And what n generates here? What is the value of n here? It is generated by random n. Earlier, what was the case? Like mean 0 and variance 1. What is the meaning of that? The curve will look like, I can show you the curve. The curve will look like, what was the case earlier? In case, what was the curve? My mean was 0. That means my mean was 0 and variance and hence standard deviation is also 1. So this was value 1. This was value minus 1. Yes or no? Because 0 minus standard deviation, that was 1, that is 0 minus 1. And what I have, so what we actually obtained, my values random number was generated from my negative values to positive values, and maximum occurrence was of 0. Okay, so this is how the number was generated, where my sigma was 1, and hence this value is going to be, and mu was 0, and hence this value is going to be 1, this value is going to be minus 1. And this is how the curve was generated. But then what I did here, then I multiplied that with 10. That means whatever value you generate, if it is 0, 0 into 10. If it is 1, then it is, now it is plus 10. If it is minus 1, then it is multiplied with 10, then it is minus 10. So now whatever numbers were generated here were having that distribution where center mean was 0, that means maximum probability of occurrence of 0 was there, and then values were going from 0 to plus 10 and 0 to minus 10, right? And then what I did, unsigned integer 8. So now which values are only remaining? Now, what will happen to all the negative values? Because my range was from minus 10, even some values were beyond minus 10 even. You can see some values were beyond minus 10 even. Some values must be some minus 10 even. But the probability of occurrence of those values is comparatively lesser than other values. But those values were existing. That beyond 10 and beyond minus 10, the values were existing. Okay. But what is the case? The values were existing there. But now, Okay, so value so that's why if I'm using unsigned integer 8, what will happen? If my values are unsigned integer 8 doesn't accommodate, cannot accommodate negative values. Unsigned integer 8 will have all the positive values only. That's why what happened? All the negative values were cropped, and that's why the shape was looking like this only. It was just having what you can say, it was having just this type of shape. If you remember, the half shape was there, only this type of shape was there. Only this type of shape was there. Instead of having these values, only these values were there. All these values were cropped to zero. All the negative values were cropped to zero. In the noise itself, so noise itself was generated like this. Noise was not having negative values. What I wanted, noise can have the negative values, right? And if it is added in my image, if it is added in my image, suppose my intensity is 128, my intensity value can go to value if my intensity value is 128, my values may go from minus 118. I mean, values can go from 118 to 130, from minus 10 to plus 10. But n never took the value negative value because I had unsigned integer 8 here, and that was the issue. That's why all the values were like 128 to 138 onwards. I hope it is making sense to you. So now can anyone tell me what this 10 defines? Suppose it is 20, what will be the change in the curve? Suppose I change this to 20. Okay, we will come to this point, but let us learn this first. So now if my intensity was 128 here, my values are going from 118, these values are 118 to 138 and beyond also, but those probability of occurrence of those values lesser compared to other values. Whatever the value was 230, 230 minus 10, 230 plus 10, all the values are existing. After that even values are there, but probability of occurrence of those values are lesser. So can you understand this curve now? Are you understanding this curve now? Are you clear with the curve? See, Vivek, if you written unsigned integer 8 n, see, you are not storing that values to n. What you have done, n, if you written n is equal to unsigned integer n, then it will create the same issue. Understood? What you have done here is you have just converted unsigned integer 8 n and you just use it to I am sure. Okay. So I guess everyone is clear. Any doubt in case you have, you can ask. If not, then you can answer my question. What this 10 indicates? What if I change this 10 to 20, 30, 40, 100, 200? What will be the change in the curve if I am changing this 10 to 20? Range is increased. Changing sense range will get increased. What will have? What will be wider curve? True, both of you are correct. Width of the Gaussian curve. What width of the Gaussian curve? What is that? What is width of the Gaussian curve? You all are correct. What is width of the Gaussian curve? Yes, it is variance. Width of the Gaussian curve is variance. This is zero, na? Width will increase. What is the meaning of that? Variance from the mean will increase, na? So 10 is actually your variance. So if someone says that I want to generate the variance sigma, and that sigma I should use here. I should provide my variance here. I'm providing it 20. Let us see how it works. See, the curve is wider now. Because of this, it is smaller. It looks like smaller because if width will increase, then more values will go beyond 255, and hence those will be rounded up to 255. More values will go beyond zero because negative values are going to come, and those are rounded up to zero. That's why two spikes are expected here, right? And if you don't want to go with that, you can have even smaller here. You'll have 15. So it will mean, but again, the values at 0 and 255 are going to be higher. See, wider curves you can see. I'm not asking about the heights. Heights are because of this values of 0 and 255, right? As it depends on how many values go beyond 0 and beyond 255. So don't go by heights, you can check the values. Numbers are fine, you can check the numbers. Numbers will remain almost similar. Okay. So now, so it is going to be variance. Okay. Now what about mean? How to change mean? How if some readings are given to you, how will you change the mean of those readings? Suppose I tell you 10, 20, 30. What is the mean of this? What is the mean of this? Too trivial question to answer, but you can answer. Okay. Now, if I say to increase the mean by 5, what will be your change your reading such a way that add 5 to what? Add 5 to what? All values, right? So that is what I want. Na? Here currently my mean is 0. If I want certain mean, if I want what means, if I want mean 2, I want mean 5, I want mean 100, what should be my code? Currently my mean is 0. What should be the change in my code? I want to adjust mean. I want to ask mean. Like here, I want my new mean, it should be mu. What I want is, yes, it should be, yes, Dipang, it is correct. I should add my mean to my noise. Here in my code, I'm not going to copy your code because I have separate one, but definitely, ultimately it is going to be same. What I am adding is mu. Mu I will add to my noise, so it will be my own, what we can say, it is my own mean that will be added here. So I should specify my mean here. I'm specifying my mean. What was the order? Order was first sigma and then mu. Na? So I will give my means. I am adding mean to 5. So now my curve should get centered at 5, 15. So it was my curve should get centered at 25. Sorry, what was my values? 15, 128, and 230, right? So my curve should get centered at 20, 132, and 235. If I want higher, no, let us take it higher so we can understand 20. So we will get the difference here. Center, just you have to look at the center because values will go beyond 255, higher values will go beyond 255, but you can see the center. Center is now at 35. It was 128 somewhere, but 128 plus 20, 128 plus 20. So now center is at 148. You can see, and 230 plus 20, so around 250. Around 250 there is a center. Getting the case, na? Noise is getting added here, and you can see your image is of course noisy. Your image is of course noisy. Right? So image is noisy. You can see the noise here as well. Okay. Here you can see the black dots because now the values are subtracted even. So it is not only just values are added and white will remain white. Here white, some values are subtracted even because negative occurrence of noise. Okay. And hence some values are subtracted even and hence it is having black-white combination. So this is my, what you can see is Gaussian noise. Everyone is comfortable with Gaussian noise? Now we will not go for gamma and exponential, that will be your assignment. Okay, gamma and exponential will be your assignment, the similar logic, similar things. Right? That is totally all your assignment, I am not going to do that. Now what is my concern? Probability of occurrence. In this case, can anyone tell me what is the probability of occurrence of noise? While value is fine, whatever the value. But if I choose a pixel in my image here, in this image, this is what my received one. What actually the meaning here is, I have this image, I generated this image. Then, due to some reason, noise got added and this is my final version of the image available. This is what I received. I don't receive my original image. I don't have my original image. This is what I received. I want to clean this. That is what my requirement is. But fine. After cleaning is a separate issue that we will take later. First, tell me what is the probability of occurrence of noise in this image. If I select a pixel in my received image, and what is the probability that it is noisy? Yes, my probability of occurrence of noise is 1. Any pixel if I will take it is noisy. Why? Because noise that I generated, my Gaussian noise or my uniform noise, whichever I have generated, I have generated of same size of my image and I added in every element I have added noise. Yes, added to all the pixels, that is true. And hence probability of occurrence of noise is 1. And this is definitely not acceptable one. This is not acceptable one. Okay, so I want to go for probability of occurrence. Before we go there, because it will be difficult directly on this Gaussian noise, it will be difficult on the Gaussian noise. Let us generate first salt noise. Salt noise with probability 1. Now, salt noise with probability 1 would look like what? How it will look like if I have salt noise with probability 1, how it will look like? Or entire right, no? So we cannot have that. So let us generate salt noise with probability point 0.2. Okay. Let us generate salt noise with probability 2. What is the meaning of that? Out of m cross n pixel, m cross n pixel, this many pixel, m cross n cross 0.2, 20% pixel of total pixel should be white. That is the meaning. Yeah? That I want to generate. How to generate? So give me the code again. So I am copying this again. What are my inputs? My input will be, I am taking it as salt noise. Whole time is fine. Image, and we are taking here is what I will need probability. I will need probability. What is the probability that you want to generate here? So I will say probability P. I am calling it as probability P. What I want is histogram is like a tribal issue right now. I don't want to see, histogram is fine. Or you can keep it even, no issues. You can see it. That's fine. Okay. Now what I want is out of m cross n cross p pixels should be white. Tell me, should I, so suppose my, what is the amount here with 600 cross 600? 600 cross 600 cross 0.2. 72,000 pixels should be white. That is my requirement. Okay. So, so whatever the input is, I want my 72,000 pixels white. Should I take from 1 to 72,000 pixels white? Should I take like that? So what should I have there? What should I, here randomness is not in my number. I know that 72,000 pixels are going to be 255. Values are fixed. What is random here? Random for selecting the pixels. Yes, you have to select random n cross p and then you have to make them 255. Totally right. So for that, what is your idea? What is your idea? For loop, yes. In case whatever code you want to write, you can write and give me the code. Okay. Let us go with your code. We have an alternate method, but let us go with the loop code or whatever code you want to give, and then we will modify it and we will make it compact. Give me your initial approach, whatever it is. I'm expecting that all of you are working on it. Keep in your mind our coordinates must start from 1. It should be integer. Here you can use random I guess. It will help you, na? What are you using? Random I. Which function are you using? Noisy pixels are that many, 2 and 1, 2 noisy pixels. Okay, m minus 1, n minus 1 I guess q, and the noise is pq, and I'm trying this as it is. Seems correct? Jainik, I'm trying as it is. Others changing? Yes, that also seems correct. We will try both. Both are almost same. Let us see. Noisy pixels are, here I should have capital M, capital N, and probability. Yes, so we go from 1 to noise, and then what should be those? Yes, noisy should be 255. Random number is generated here. Random integer is used here. He has used random number, random function. Right? You have used both of them are fine. I think both of them will work. I will change that. But m minus 1 will be fine, right? It will be m minus 1. I have not checked. I'm not concerned about m minus 1. It will be, yes, totally m pixels are there. So will it be m minus 1 or m only? Just check that. Put in pure logic or everyone can check it. Because I want 1 to m, na? I don't want 0 to m minus 1. Jenny, will this work? Oh yes. Thank you, Maliha. I will need it. I'm changing this to Pro. And tell me about this m minus 1. I feel that it should be m and n, but it should be m. I also think so. Jainik can answer the best here. Am I correct here? Jainik, should I use m or m minus 1? Right. So I'm changing it to m. Tell me about any other range if required. Noisy, I should write noisy here. That will help me. Or noisy, it should be noisy. But the problem will be I should use image here. Image value should be 255 at that location, and my noisy itself is my image. So tell me if any further change is required. I guess many. I don't think that. I mean, you should tell me the changes. So here the values are generated from 1 to m, 1 to n. Brackets you can check, and the image location should be 255, and that should end with this. Seems okay. Okay, let us see whether saving it solved and random n is, so you should use m minus 1 if it is 1 plus m. Okay, that's why m minus 1 is used. No? So okay, Chintal, I am following that. True. Then you were correct earlier. Okay, any other thing that we should follow? Seems okay, na? Otherwise, let us see. Then we will come back to change, right? Right now, I'm feeling it is okay. Then we can come back and check. It is not working. So I will use here salt, and I'm not going to use this image now because salt and pepper we can try it with other images as well. So we will get the better idea here. So I'm using that some other image. I'm using this 2.jpg on this part, that is the image of that high contrast image of that cake. So let's see whether it is showing us the image. Seems that it is there. I need to show and help us get original image. I can show you the original image so that when noise is added, you can see the difference. This is that image, right? This is that image. Okay, so what I want to do now is, so I am using this image. I am not using the synthesized image, but in case I will need, I am keeping it here. I don't want this uniform noise now. So what I did, I took image and I will give the probability here, 0.2. So 0.2 probability is given. Noise image in histogram is generated. What was the problem here? Why this happened? Noise is generated, but some issue is there. What happened? The coordinate values were generated. There is issue in coordinate generated. Na? I can show you the output. I can show you the code. Can anyone judge what is the issue here? So what should I do here now? Bhavik, it seems correct. Maximum it will be 255. So I should use round here. The unsigned integer 8 is not for the rounding purpose. Rounding that is definitely correct. Seems true. Seems correct. I am using it round here so that it will be integer. Otherwise, my maximum intensity is my maximum coordinate will go up to 255. No? That is 100% correct. Seems so correct. Let us see whether it changes or not. Ha, it worked. It worked. So that was the issue. So this is how the random noise with certain probability. So I am reducing the probability now, and it is going to work. It seems that it will work. I am reducing the probability now. And you can see this less number of dots, even if you want to reduce further. See, so you can see that the dots are even lesser. So this is how salt noise with certain probability we generate. So now only if I want to change with the paper noise, what will be the change here? If I want to do with the paper noise, here it will be just zero, no? It will be just zero. And this is going to be my paper noise. Yes, 255 is replaced with paper noise. Saving it. And I'm changing it here as well. Let us try. It should work. It should work. As expected, paper noise is generated. Okay. Now next question is for salt and paper. What should be the change? Salt and paper. What is the meaning of that? Certain are white, certain are black. Probability is given 0.2 for salt and paper. What is the meaning of that? Half are white, half are black. Randomly 0 and 255 is fine. But how many zeros and how many 255s? Zainab. 0.2 is my probability of certain paper noise. Then again it depends on you, that it is your code. You can have different probabilities. What is even? You are talking about iterations. Even iteration 255 is 0. It is even then. I mean, I value you are talking about. If I is even, then we have 255. Otherwise have 0. Real and beta. That yes, that is what I was talking, Jainam. Yes, Priyal and Gata and Jainam, pay attention now. Priyal and Gata they are suggesting that I value, if it is odd, then we should take it as a 0, and I is even, then take it to 5, whatever you want to keep. But here, what will be the probability of occurrence of salt noise? It will be half of the total probability. Suppose if I say noise occurs on 0.2 at 20% pixels, then 10% pixels will have salt and 10% pixels will have paper noise. But what Jaina is asking here is, can we have, can we define it randomly? Yes, you can define it randomly as well, just you have to write different code. So we are going with that only, that salt and paper will have different probabilities. For simplicity, if I want to keep it half, I can keep it half, right? Just I will do it. What here? Here I will just keep a check of I, and I will put values 0 and 255. It will be very easy. But that is not my requirement. My requirement is to have random placing of 0 and 255 different probabilities. So can you suggest me the code for that? Jainam, Priyal, Beta, and anyone else? What I don't want half zeros and half white. I don't want that. I want no. You have to give me the code. Zainab, I'm waiting for your code. So what I can have, I can generate a random number there, and then I can take one minus random number for white and one minus random number for black. Quick. So because we have to go for many other things. Okay, so here it is totally defined by random function. If random is equal to 0, it is 255, else it is 3. Fine, it will work. Let us keep that. But if you want to predefine values of p and we will use round. If you will use round random, then won't it be like all the values will be again the probability is 0.5 na, then because values are uniformly distributed between 0 to 1 na? So it will be probability 0.5 if I'm using round there. Go with some other idea. Hmm. You can just use random. That is fine. Random integer between 0 to 1. Then it's the random number again, but the probability will be uniform distributed between 0 to 1. Again, the probability will be only 0.5. Na? But I think we stuck in some tribal issue. If someone will suggest you, someone will suggest you some probability, suppose as a user I am suggesting you probability 1 that is for your white noise, then you can have probability that is salt noise, and probability 2 for your probability 2 for your what you can say probability 2 for your what we can say here is probability 2 is for paper noise. Then you can change this probability 1 here for, and you can have this 255 probability 2 here, and you can have what we can say, you can have 0 here, probability 2 for paper, then probability 2 here and 255. If you some only one probability is given to you, what you can do is you can have normal distribution, or what you can have this uniform distribution, but in that range you can have from say 0 to zero point 0.2, generate a uniform distribution between range from 0 to zero point 0.2 that we had, that from A to B, here my A will be 0 and B will be zero point 0.2. You can have any random number, right? So that probability, so what you can have is, suppose whatever this probability is, you can use this range from 0 to this probability, from 0 to this probability, generate a random number, which will be your probability for your what we can say salt, and otherwise it will be 1 minus that value will be probability for your paper. In that way also you can generate. Okay, right now I'm taking the last suggestion by Maliha. What is that? I'm taking this random I 0 to 1. Okay, random one, and that I'm using here, or we can, or ready-made, or this ready code is there. I'm going to use that by random. That is also convenient to me. That's why I'm using it right now. I'm using it, and this should work. I guess this should work. Let us see whether it works. Everyone please check whether this code will work or not, because I want to go with a better case. Time is limited, so I want to go with some better issue. So I am skipping this portion. I think you can understand it. I am going for salt and pepper. I should change the name here as well. SNP noise. SNP noise. Salt and pepper noise. Okay. And what I am giving here is uh, so what should I do now? Is this one? 0.5 probability at least. Or I is also fine. A modular I you can say that you also you can take. And so let us see. Let us complete it. What is the SMP noise? As expected, salt and pepper noise with equal probability seems it is equal, right? So as expected, see again if you want to go with the probability thing, it is very simple issue. I don't think so, a little bit thinking will work there, so I don't want to waste time there, but that you can try in your free time. Yes, so this is salt and pepper. So as salt and pepper with the required probability we have created. Probability changing is going to help you definitely, but directly making it very less should help. As expected, it is helping. See, it is helping. So this is so how I generated my salt and pepper noise. Next case is of generating Gaussian noise and uniform noise with some probability. I want to modify this. I want to modify this code. And I want to give not only sigma mu but also probability. Tell me the changes. I want to change this way. So I want to generate, I will correct my spelling here. Gaussian function I will generate and Gaussian. Okay. So um, what will happen? What are the changes? So what was the earlier case here? First of all, I have to decide how many noisy pixels I have. What will be the change in this if I want to make that? Here instead of 255 and 0, what should I do? I should go with this. I should take this. How to do that? Tell me for this. What I want is for those coordinates, the noise should be generated and those noise should be added. So what will be the change here? Yes, it should be image plus n instead of 0 plus 255. Okay, let us change. So I am copying this as well. Noisy pixels, this required. This. Noisy pixels are fixed now. Up to noisy pixel, what should I do? I should generate the noise and I should generate the noisy image. Okay, so this seems noisy should be return back. Okay, and it's fine. Let us see any changes should be there. Please verify. Did I change anything here? Okay, so now I am using this function. I am saving this function first. Index should be random. Yes, index should be random. No? Oh yes. So what to do? Huh. So tell me, so how? Yes, index should be random, and this will be what I don't want to generate for all the pixels. No, so this is totally wrong. Of course, it is wrong. Thank you, beta. It is wrong. You can correct it. My Nidhi, Maliha, please verify, check. See what will happen here. Noisy pixels are not having any use here. No, it will generate my random number from of the size mn, and where it will add? It will add to entire image. This is not going to give me the one. Okay, so I am keeping the code of. I should keep this right. I'm keeping it in my noisy pixel. So I am first. I have generated random locations. Random locations are generated, and I should add on those random locations only. So I should add on my random locations, and only those random locations should get altered. Only those random locations should get altered. Otherwise my noisy image should be as it is as my image. I hope you are getting the case. So only those locations are altered and n is added. Now what is the change here? What should be the change here? It should be, if I will remove m n, then what should I write here? Just random n, it will work. Or should I write 1 1? N will be single value. I have not generated entire pixel. What I am doing here is I am generating random single function, single value. N is not a matrix here. Understood? So if I am generating matrix, then it will be n of p. Oh, that also can work. I can generate a matrix of mn, and then I just take that value of p. That also can be fine. But it will be very crucial to generate every time this mn matrix, and then just take one value out of that. Right? So I'm okay. So I should keep what original code of noisy pixel. Okay. What this suggestion is what noisy pixel value should be as it is, and make 20% pixels 1 and other 0. Okay, so just use the previous code of I think Gaussian and just mask them. That is what your point is. Okay, understood. So what he is saying here, what Vivek is trying to say, generate entire matrix, entire matrix of this Gaussian noise, and that completely any you should generate, and just mask other values and just keep 20% random pixels as 1, other values should be 0, and just multiply it with the n and then add it. Yes, it will work. It will work. Here, what will be the issue? Here, what will be the issue here? What is it? I can keep this. I think that Vivek's idea is better here. The reason here is, if I am taking random n, that means what is the meaning here? That out of this random distribution, generate one such number which follows the random distribution. Next time when random n is called, what will happen? That one will follow the random distribution. What I want, that all the noise, all the pixels, entire noise generated should follow the single Gaussian distribution. Every time every time I don't want a value from a different distribution or different random distribution, right? What will happen if I am I'm not sure whether I'm making sense here or not, but what I can repeat my point, and that is what important point I have here is, see, now what I want to generate a noise in which certain pixels should have certain, in the certain pixel have certain values should be behaving at certain probability. Certain pixels should have certain probability, certain values should have certain probability. That is what my requirement is. That's why what I need, I want to generate entire Gaussian noise together. Whatever, suppose I have say 600 pixels are having error, 600 pixels are having noise, those 600 pixels noise should behave like this. Understood? So what I need is that entire noise should be generated together. It should be generated together. That is what our requirement is. I doubt if I am generating random 1 1, what will happen every time it will take a random distribution and it will generate a number from that. All the numbers by generating that 1 1 case, if I am to get bringing together, will follow this curve or not, that I am not sure about. So so here we have two ways. One is what those who are preferring 1 1, they can generate this 1 1 and can see the curve of the noise only. That is also fine. Nidhi's idea is even simpler. No need of keeping the mask even. Just generate the matrix and just add those values. Otherwise, you can ignore n. That is also fine. So it is even simpler. So I am going to opt for. I'm going to opt the Nidhi's approach because it is. I feel it is simple. A masking issue is also simplified here. So let us change the code. I hope you are getting the case. What was my point? Again, so I have two approaches here. Either I can go with this approach by suggested by this by Nidhi and Vivek and all, and or we can what others can do is they can generate they generate the noise by 1 1. They can keep all the noise together and they can see whether that noise generated by 1 1 follows this curve or it is giving us a random nature or it is giving us the random nature. Possibly, because we are having the same mean and same sigma, possibly we will have the curve. Even if I am using the numbers with 1 1, I may follow the Gaussian curve. But still I am not sure, so I cannot take risk right now. So what I am taking here is, I am following this suggestion. What I will do, first I will generate the noise pixel for entire one. So I should keep it outside the loop. So every time it will not be required. So I am generating ML and then generate PQ and then don't generate it here and just add those PQ. Will work? Easy. Check it. All others, please check. Mind your idea works now. You could have suggested there also that we can keep it outside. It is easier, na, Mayank? All of you please verify whether it works. So quickly we can run and we can conclude it. Good. So now we are going with this file name. Thank you. It is okay. I forgot that, so I'm keeping it like this function. Thank you, Prinish. It was helpful. Here I will take the Gaussian GAU. What I'm doing with Gaussian, but I don't know. GAU. Okay. And what are the parameters? Sigma, mu, I will need. So what was mu and sigma? Mu was 5 and sigma was 10, I guess. And then probability 0.2. Um, First was sigma, na? Sigma, then mu, and then probability 0.2. Let us see whether it works or not. Yes, you can see it is working. Probability, if you can see some noise is visible here. Noise is visible here. Okay. So see, yes, noise is there. Okay. So it is noisy image now. But definitely, as time is limited, I'm not checking, I'm not verifying it much. But in your feedback, you definitely check. In case any corrections are needed, you can definitely tell me in the next step. So I guess you are clear with how to generate noise, what is the significance of noise, how exactly noise occurs. I mean, how exactly you can see your noise. It occurs because of some reasons, but how you can see as you see your noise. Okay. So I will put this put exercise of this soon, maybe tomorrow. Okay. You can check, and any doubt in case you can ask me anytime through mail or through in the next lab or in next lecture. Anyway, any doubts so far? Okay. What is remaining for you? Remaining for you to check for the Gaussian. Seems that it is working, but still you need to verify it properly. Okay. Here we cannot expect the curve. We cannot expect the curve here because see, but still you can see some shape is there. But you cannot expect the entire curve here because all the intensities are there and all the quotient curves shifted and all the intensities are mixing up with each other and hence this and any random shape is there. But still, if you can see some shape, something is looking like Gaussian. That's why I can see that some Gaussian noise is added here. But still, you can verify. Okay, so I am concluding the laboratory here. Any doubt in case you can ask me anytime. Okay, so for now you can leave. See you in the next lecture.